So regarding the debates, first of all, I want to ask you for a thumb vote on how that was as a use of our class time compared to other class time. And I don't mean entertainment, I mean learning content and thinking about issues relevant to apes. It was way better than average, about the same as when you lecture and show movies and whatever, or this was a waste of time, it's better to lecture or better to show movies or whatever. Sour losers, anyway? Okay, excellent. Next. How, specifically now, if you've done debates in other classes, how does this debate compare to the debates in other classes? Specifically, not on a thumb vote, but like this one was less or more or better or worse because...
Usually there's more structure. Like when I do formal debates, usually like you have this amount of time to do your opening, you have this amount of time to do cross-examination, you have this amount of time to do your body, like subsequent speeches, and then that closing. And I don't know, it's usually just more organized like that.
Okay. What else? Compared to other classes, has nobody done a debate in another class ever? Yes?
Last year in world history, we did debates, and I thought it was much more organized, plus like the use of actual facts is nice.
Okay. What else? How disorganized was your world history debate?
It was just a lot of yelling. So lack of yelling.
That was debating the 30 questions.
Yeah, it was like Mark Rose, Patrick Calder, so everybody.
Got it. It's kind of a free-for-all,
Yeah.
split the class down the middle and go for it?
Yeah.
Got it.
It's great.
Yeah, that sounds fun. What else? Any other comparison to other classes? Your second period has a ton of stuff to say. Either way, just any comparison. So compared to this other class, nobody else, huh?
In English, we like fish the kind of seminar.
Okay. Nobody else, huh? Yes?
Well, like, I did a debate like 3 years ago, and we had to write out essays, and we kind of like read it off, and we kind of stood up in front of the whole school, and there was another debate team, and like we rebutted, and like everything was like extremely organized.
Yeah, I mean, that's a more classic debate format. And I have to say the reason I'm not really into that in class is when everything is prepared and written in advance, it's really hard to focus on a single part of these big questions. And a lot of times, kids' writing skills are more of a challenge for the audience. Like, there are a lot of students who, if they had to read an essay, would confuse or lose all of you, or would be off point. It's not as lively for the audience to do that format, even though I know that that's a more critical thinking for the debaters, because they have to actually put more thought into what they're offering. So how could I improve this next year? You know, this class had great debates. I was hoping that it would be memorable enough that you would be able to give me more feedback than this. I'm totally open, anything good or bad. Yeah.
Maybe have more.
Except for this.
Maybe have more like topics that are like more like quite biased in what people choose. So if there's like a topic that you know is going to be like an even amount of one affirmative or negative, and let people choose so they're really passionate about it, and it's, people are really interested.
Yeah, it's just tough because demographically, a lot of you are biased toward one side. So either by your age, or by your socioeconomic status, or by the courses that you're taking this year. It's tough to find a 50-50 split on most population issues. But I would like to make people more passionate, yes. Or encourage more passion.
I really like putting through curveballs, and we changed it up because a lot of the debates were just fact versus fact. Like a lot less rebuttal off what individuals were saying, and a lot more just research thrown at each other. So when you like change it up, it forces kids to freestyle.
Yeah.
It's really cool.
I like that too, and I'm trying to figure out how to do that. You mean as an audience member you like that?
Yeah, and also debating as well. That was fun.
Cool. Yes?
Maybe like somehow being able to see how a previous debate had gone, like one from last year or something. Or, I mean, I know you didn't want to talk about it because then it would give the other team ideas or something, but I had no idea what my topic meant at all. Like, I was so in the dark.
I'm kind of trying to figure out how to ease that burden on so many students while still get that outcome for more students. A way that I'm thinking of doing this is instead of giving you a single sentence about your topic, to give you a series of like a big explanation of your topic, like, in my opinion, the deep thoughts are blah, 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 and basically this comes down to blah, 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 and some of the big questions in this issue are blah, blah, blah. And then when the kids show up, I would ask a few leading questions. So now the economics, and now the moral issues, and now the environmental impacts. How many of you think that would work better? How many of you think that would just be too much crap to add to the debate?
Oh,
Always on point. I love it. Other commentary?
Yeah.
Yes?
Yeah,
Yes, Lane?
maybe to help soften the confusion, just have the question be worded as a resolution, like resolve immigration is beneficial to our society, and then you have pro and con, because everyone's really confused when going up, like, am I affirmative or am I negative? If you highlight pro, con, it makes it easier also to look up, because there's like a website called procon.org, and it will have, I swear, every single topic you ever think of, and it's just right there and easy.
Yeah.
Makes sense.
Very good. What else? Nothing else, huh? Did you hear a debate team in the high school?
There's just JSA, and then there's mock trial, and that do
All right. Anything else, no matter how left field, about the debates? Personal feedback? Jose, I don't like your shoes. Anything?
Don't like questions.
All right, then. I'd like to finish up assignment 6.4 today. Yes?
Well, immigration debate was kind of like they were arguing the same thing, almost. It's one side was arguing immigration is a good thing, or illegal immigration is a good thing, and they were just arguing immigration is a good thing, so legal is bad. So they keep finding a common ground most of the time.
It's hard for me to create the extreme divide because we're always prone to agreeing in the middle. And so I don't know how to phrase the questions and push the kids to the really extreme, which I think is where it's interesting. Because when we all get in the middle, we all handshake. That's just boring. Yeah.
Were there any debates in all your periods where like someone in the audience stood up and like called someone out?
Well, in period number 6, I had a couple of students that are just born to perform. They're just like natural performers. Zach Parent and Adam Parker and David Ceballos. I don't know. Yeah, I mean, it like in some of them, they were like exciting because the kids were so expressive, but it was their own kind of excitement. It wasn't like the audience was engaged with the conversation. It was like, that was a good joke, that was a good joke. And so entertainment value was pretty high. I had a couple of students who had something to say about a topic, but never during the debates. You know what you get most often as audience participation is actually mockery. Like, oh, did you hear what Nick just said? What an idiot. Like, everybody just like laughs about, like, oh, that was a big fumble. But not like, wow, that was a great point. A couple times. All right. So I think we left off on study goal number 60 in assignment 6.4. Hey, Sarah. If everything is totaled in all of those periods, I think you guys are both solid. Thanks. Yes. So in you'll have to use that one to hide the video screen. In number 60, you'll have to let me know how far we got in this period. Did we talk about the increasing likelihood of a big earthquake because humans cause little earthquakes? Okay. Did we talk about New Orleans and Hurricane Katrina and how that city is essentially doomed for a number of reasons? All right. So in number 60, I have some bad news for you. We used to talk about natural disasters as quote-unquote acts of God. That's technically like insurance policies are written to exclude acts of God. And a lot of people are surprised to notice that what used to seem like random natural events are either being exacerbated or accelerated by humans. Almost every type of natural disaster is becoming more hazardous, more common, or more severe because of humanity. So I have a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 types of disaster. I'm sure you wrote them all down in number 60 because you do your homework because you're a good student. For those 10 types of disasters, I'd like to discuss how humans cause them or make them worse or make them more common. First, earthquakes. I need to be really clear about something. Humans do not cause giant earthquakes, the 7.8 on the Richter scale. Humans don't cause those. But you should know that a little earthquake can set off a big one. How many of you have heard this already? And humans can cause little earthquakes. There's 3 activities. Number 1, deep well injection. Deep well injection is when we get rid of liquid waste by pumping it deep underground, especially fracking fluid. There's a misunderstanding. I don't want you to make a mistake, so here comes a detail for the nerds. Fracking is when we use high pressure water to fracture bedrock to release fossil fuels. We'll talk about that in the next unit. You use high pressure water to break bedrock to release fossil fuels. It's called fracking. Now, that is a very localized and shallow geological feature. So that's not actually what causes the earthquakes. It's not the fracking. This is the detail. It's not the fracking. It's what you do with all that fluid after the fact. The most common way to get rid of fracking fluid is to inject it deep into the ground, where all that extra liquid affects pressure and temperature and friction rates among rock. It appears that disposing of fracking fluid is one way that humans cause little earthquakes. Remember, again, it's not like those little earthquakes are a big deal for humans, as if they might set off a big earthquake. The second way that humans cause little earthquakes is with geothermal energy. Apparently, when you remove heat from rock, it cools off. That should be obvious. And as the temperatures change, the densities change, and so that can affect slippage. The thermal changes from geothermal energy can cause earthquakes. The third way that humans cause earthquakes little demo for you.
Are you gonna make it earth?
Watch me. Tectonic plates are always moving. You guys realize that, right? They ride on a bed of red hot and those plates have always had about the same weight, in geologic history. And so those plates have been moving at roughly the same rate for at least hundreds and hundreds and thousands of years. Until we add a really heavy thing on top, what's going to happen to this paper?
Yeah, that's the thing.
See how it crinkled? Reservoirs made by dams cause small earthquakes because they add drag to the tectonic plates movement. Does that make sense to everybody? So to review, disposal of fracking fluid by deep well injection, geothermal energy, the temperature changes cause pressure changes, and dams, because the reservoirs add drag to the tectonic plates movement. Number 2 is volcanic eruptions, and I can tell you for sure that so far, that remains in the hands of the gods. As far as we can tell, humans have no effect on volcanic eruptions. This is probably the only natural hazard unaffected by humans. Now, landslides are largely affected by humans. And you might know about a really famous example because it happened in your own backyard. How many of you know where La Conchita is? Does anybody live in La Conchita? Does anybody know someone affected by the La Conchita slide? Does anybody know somebody killed by the La Conchita slide? Okay. So, La Conchita is a perfect example of the 3 ways we make landslides worse and more common. Number 1, if you have a hillside like this, it's not going to slide too much. But as you build houses and push back the slope, now it's more likely to slide. Our construction increases slope angle. That happened in La Conchita. Number 2, nobody likes that scruffy, funny-looking native vegetation, so we remove it. And the removal of vegetation means there's more runoff, and that gets the slide going. And number 3, La Conchita is a perfect example. Can anybody see what's immediately above the slide in the large picture on the right? It's actually an avocado orchard. We irrigate. And irrigation makes the dirt heavier. It's already mud when the rain hits. So you'll notice there's even some avocado trees in the slide. By increasing the slope angle, removing native vegetation, and adding water to slope soils, you can pretty much guarantee a landslide. BT dubs, a separate exacerbating factor, also in addition to 1 to 3, is rain patterns are changing due to climate change. So a lot of areas have just had good luck, but now they're going to get more rain. Extreme weather events are more common now because of climate Number 4 on the list of disasters is hurricane. And there's a really tempting tendency, especially in the media, to blame a natural disaster on climate change. How many of you heard a news story that said Hurricane Sandy was caused by climate change, or the Philippines typhoon was caused by climate change? Hurricane Katrina, people attributed that to climate change. I hope that you'll understand this difference, because it's really the difference between a scientifically literate person and a scientific layman. Remember, you can never attribute a single event to a single causative factor if there are other possible causes. For example, if she's a smoker and she has cancer, do we know for sure that her cancer was caused by the smoking? It could be because she lives next to a power plant. It could be because every one of her elders has cancer. It could be because of other things in her diet. It could just be genetic. It could just be bad luck. It could be solar radiation. And it could be the smoking. Does that mean that smoking does not increase cancer? No, smoking does increase the odds. You just can't attribute the single event to a single cause if there's other possible causes. Does that make sense? Remember, a hurricane is a natural thing, but climate change makes them worse. Just so that we're clear, the number of tropical storms is cyclical, and that cycle seems to still be in the hands of the gods. So the number of hurricanes per year follows a sine wave pattern from somewhere in the low 20s to somewhere in the high 20s. That's every single year. That number just goes up and down. 25, 26, 27, 26, 25, 24, 22, 20, 20, 22, 24, 26, 28, 30, 30, 28, 26, 24. That pattern is just a natural about the number. But they are becoming stronger on average. Anybody want a 5 on the AP test? So here comes your nerd detail. Water has a higher specific heat capacity. So when you heat the planet, you're actually just heating the ocean, not so much the air or the land. Everybody know that? Because water holds more heat than many other substances, global warming mostly means ocean warming. And that's the problem. When the planet gets hotter, the oceans get more hotter than the air. Does that make sense? The severity of a hurricane depends on the difference in ocean and air temperature. So when you're only heating the ocean and not the air, when a hurricane hits, it'll be more severe because there's already a bigger difference in their temperatures. That's how you get a 5 on the AP test with those details. Water has a higher specific heat capacity, so global warming equals ocean warming. And because hurricane severity depends on the difference between the air temperature and the ocean temperature, global warming makes hurricanes more severe.
What was the phrase, water has a higher...
Specific heat capacity. It means it takes in heat more than other things. This is why you can drown, why you can die of hypothermia in 85-degree water. If your body's 96, your heat will be lost to the ocean. 85 is still enough to get you too cold. Your body's running at 96.7 or something, right? So 85 water feels really good for a little while, but you still get really cold.
Oh yeah, you do start shivering.
Yeah, I mean, if you spend like 3 hours surfing in the ocean, you freeze your ass off even if it's 90 degrees. Especially if the sun's not out. Okay. Tsunamis are, let's be clear about something, they're caused by tectonic movement underwater. A tsunami is made when stuff moves under the water. We don't cause tsunamis. And climate change, as far as we can tell, doesn't make stuff move underwater. What's happening with tsunamis is humans are removing the natural protections. Like in New Orleans. They're cutting down the mangrove and coastal swamps. They're removing sandbars. Here's a little fact that a lot of people don't know about tsunamis. In many parts of the world where you have giant coastal swamps, the tsunami doesn't reach the shore. Because the coastal swamps, like a comb sticking out of the water, will catch all that extra water and slow it down. Does that make sense to everybody? If you can take away some of that impact force, then by the time it hits land, it's just like a little... But when you get rid of all those coastal swamps, then that water just hits the land full force, and it's moving faster, and there's a bigger difference, and it's more flooding and more damage. So the removal of natural protections has made tsunamis more harmful. Now, sorry.
If that tidal wave hit Santa Barbara, would we be fine because of the channel on?
Well, it depends where it starts. If it originates in the channel, then we're totally screwed. If it originates outside the channel, then the islands would mostly block it. Although the funny thing is that tidal waves are usually just a rise in the water. So when the islands are here, the water still rises around them, and it just backfills as it goes around. So not very much protection.
Right.
It would slow down and refract, and to some degree filter the wave part of it, but technically it wouldn't offer much protection from a big one.
And if a tidal wave originated...
The Japanese one still flooded the harbor.
I did it?
Yeah.
Um,
Anybody know boats damaged? Did you know boats damaged by it?
If a tidal wave originated within the channel, could it still do a ton of damage?
Sure. Okay. Wildfires. We've talked about a lot of this. Wildfires, I think you should know by now, right? History of fire suppression means we've got more fuel there. But there's a couple of other problems. The West is in a drought period. Because of global warming, many areas are either getting hotter or drier. So because of global warming, there's extra fuel, like in Colorado where all the pine trees are dying. There's more drought, like in the American West, where rainfall patterns are shifting. And temperatures are higher, so when the fire gets started, there's already more heat in the system. Wildfires are really creepy. One other problem with wildfires is people are living closer and closer to wilderness. We are encroaching on wilderness more. So we have a history of fire suppression. Climate change causes droughts. Climate change causes heat waves. Climate change kills forests and adds fuel. And humans live closer to wilderness. Tornadoes is kind of a goofy one. We know tornadoes will change because of climate change, the places where they happen, and that's all I can tell you. Tornadoes are kind of a fluke in weather. You guys realize that? The best predictions we can give you for a tornado is under 2 minutes. That's like the best we can do. And sometimes you get like a 30-second warning if you're lucky. Tornadoes are kind of like, wait, there's a tornado! And then it's like, whoa, and now it's gone. You hear about storm chasing, the idea of following tornadoes around. It's really difficult. Because they're so unpredictable, there isn't like some basic formula about where they're going to show up next. All we can say about tornadoes is that the areas with a lot of tornadoes are changing. They're showing up in new places. For example, LAX had a tornado a couple years ago. Goleta had a small tornado a few years ago over by the Deckers, by the new Deckers building. Los Carneros and Hollister.
How big?
It was pretty minor. There wasn't a lot of structures there, but I think it knocked over an outbuilding and ripped some tiles and knocked over some trees and stuff.
I guess taller than the river.
say about tornadoes is they're probably going to pop up in new places. They're too complicated to really make predictions about. There are a number of things that cause more flooding. One of the things is kind of difficult to explain, so this is somewhere where I'm cutting into next unit here. Anybody know what channelization means? Anybody seen the LA River? Where do you see the LA River? What part? From the freeway?
Yeah.
How does it look?
Dry. Concrete.
Yeah. Cities need to get rid of their water. Do you guys understand that? Because water makes it unsafe for driving and makes houses rot and makes mud and makes slides. So keep in mind that cities basically have a giant continuous umbrella. There's the roof out to the sidewalk, out to the gutters that go into the ditch, that go out to the river that's now a concrete gutter. Does that make sense? We shed our water, cities get rid of their water. So imagine if Nick City is dumping all of their rain into the river, what does that mean for me if I live downriver?
More water.
Exactly, I've got more water coming at me. Because cities need to shed their water, we get more flooding downstream. So the problem with flooding is there's some parts of the world that don't absorb their rain, they just dump it on people downriver. Urbanization, downriver of cities especially. The other problem is that we often remove forest or change grassland into farms. So instead of having habitats that absorb rainwater, we get more dumping and erosion. Also causing more floods. Has anybody noticed that the number of deaths due to heat waves keeps growing up? I don't know if you've noticed, but like last year, I think in London there was like a crazy number. Yeah, you still have connections with England?
Yeah.
Did you hear about last summer the biggest number of heat wave deaths ever in history?
I didn't hear the number, but yeah, it was like a pretty serious heat wave, like it's been the longest period of time I think it's ever been.
Yeah, that's right. This is a funny thing about climate change, kids. We've had more cold snaps recently and more heat waves recently. The averages are splitting into the extremes because of climate change. Many hot areas are getting hotter, many cold areas are getting colder. And so we have a jump in extreme weather overall. Heat waves are becoming much more common. And the other problem with heat waves is called the urban heat island effect. We live in cities, and cities get hotter. This is a new vocab term for you. Can anybody imagine why cities would be hotter than a forest, for example? Yeah, the concrete and the asphalt and the steel, they heat up. Like, you ever notice on a hot day that the trees still feel nice and cool? That they can sweat to get rid of their heat. They also don't absorb a lot of heat. When you go touch like a big steel skyscraper, or like a bunch of asphalt, or like a concrete statue, that stuff gets really effing hot, right? Cities have what's called more thermal mass. They're darker and they store heat better. Anybody know other reasons why cities heat up? There's a few. They have less circulation. They generate their own heat. I mean, think of all those cars. Do you guys realize that cars are about 10 to 15% efficient? The rest is lost as heat. So all the gasoline that's being used by Los Angeles, about 80% of that is just being burned for heat in the city. That adds a lot of heat. All the electricity, 50% efficiency in transmission through wires. The rest is lost as heat. All those light bulbs that add all that heat everywhere, all this heat. Finally, there's this thing called evaporative cooling, that forests can cool down by sweating. You know, the same way that your forehead cools down by sweating. When you evaporate water, heat leaves as water vapor, right? Heat transforms liquid into water vapor and leaves. Forests have that air conditioning capacity, but our cities do not. And so check this out. If you take the temperature outside of your city, there can be a 10 to 15 degree jump in less than 1 mile just by going into the city. Cities are much, much hotter than their surroundings. Where do people live? In the forest or in the middle of the city? So when you have like a little heat wave, that's going to be a giant challenge in the city in particular. Yeah?
If LA's average temperature, let's just say, is 70 degrees, if LA was left untouched by civilization, it's just that area, what do you think the average temperature would be?
10 to 50 degrees less. Some cities have different patterns, by the way. So Los Angeles, coincidentally, is kind of a fluke of climate. It's guaranteed to have inversion layers because of the cold marine layer coming in. Los Angeles may be a bad example. But if you choose Las Vegas, there's no doubt that in the open desert it would be much cooler. Being desert, generally there's less, because part of the urban heat out doesn't apply. There's no trees to keep the air conditioning. Philadelphia, like definitely giant urban heat out, that's for sure. Okay, I'm almost done with these. Silence. The last one is drought. And just to give you guys some bad news, most of the forecasts say that our part of the world is heading into long-term drought. There's like these big mega cycles, and we're entering a dip in water deposition in the American West. That's not related to climate change necessarily. So in drought, there's like three big problems with drought. One of them is that sometimes people just take water from each other. So one group of people causes drought for another. Because we take so much water from the Colorado River, there's very little water left to go into northern Mexico. So in that sense, some people using the water makes drought for other people. If Nick is watering his farm, and Samantha's using water for her factory, then my city might not have a lot of water left in the river. Or the groundwater, by the way. So, some people just take it from other people. That's sort of drought. Of course, climate change shifts the areas where rain falls. So if Athena's river used to be the one with a lot of water, now she's experiencing drought. And my river, that used to be pretty dry, all the rain is falling on me, I'm experiencing floods. Remember that when climate change moves stuff around, both extremes happen. She experiences a change for the less, called a drought. I experience a change for the more, called a flood. Yeah?
If the American West is in the long scale drought, what would happen?
It's reasonable to assume that the planet has the exact same amount of water, right? The water volume of the Earth hasn't changed. So it's always, where is the water living? Will there be more precipitation here or more precipitation somewhere else? More evaporation maybe, so there's more in the atmosphere? Less living as snow, more living in the oceans? We will talk a lot about these things in the climate change unit, the atmosphere unit.
So, because there's the same amount of water always, does that mean like when you drink it and stuff, it just comes out as like sweat and pee, and then it's still the same amount, like it doesn't...
Yeah, I mean, essentially our globe has a fixed volume of water. The question is what percentage of that is available to us? When more of it goes into the ocean, less is left for us when we go and use the fresh water. When more goes into the atmosphere, maybe that's going to make more rain, and that would be good maybe for us in some places.
But none is ever lost.
But none is lost from the Earth. I mean, notwithstanding unusual chemicals, I think. The last problem with droughts is that climate change is melting glaciers. So here's the funny thing. Glaciers are rhythmic, especially in the short term, in the year to year. Most glaciers do this, watch. In winter they get taller because they're storing snow, and then in summer they melt and feed the river. Then next winter they absorb snow, and then the year after they melt. Funny thing now is, because of climate change, most glacial areas are not absorbing very much, and then they're melting a whole lot. And so the funny thing is, some parts of the world have a couple of years of flood as their glaciers overall are melting, and then they're going to get into long-term periods of overall drought because now there's no water storage uphill anymore. I find it really fascinating that a lot of the stuff we used to call acts of God is something that humans can kind of push around a little bit. Yeah?
When a huge python fell in Mom's car, she got repaired for free because it was an act of God.
Yeah, I mean, that some acts of God are covered by insurance. Some of them are not. Carry on. Okay, our last medical to discuss in 6.4 is number 62, which is your warm-up. There are 4 reasons why disasters are becoming catastrophes. I don't know if you've noticed, but like every time I turn on the news, it's like, the earth is out to kill the humans, and there's like some catastrophic earthquake, tsunami, typhoon, hurricane, flood, some bad news. You should probably be a skeptical watcher of the news. One thing that happens is we just have better reporting. So you hear more. 100 years ago, you just wouldn't have known that Turkey had a big old earthquake. So on one hand, catastrophes aren't more common. We're just seeing more of them from our easy chair. But there is a couple of reasons why stuff that would be a bummer is now a really big bummer. So we're increasing the harm of these natural hazards. Anybody know those 4 reasons? This was number 62. You should have done it as homework. Yes?
More people are populating in these strange areas, so where a natural disaster would occur and not, just affect like trees or animals who naturally were there, it affects people now.
That's actually 2 separate things that you said. One of them is that we have a higher density. So back in the day, if a hurricane hits his neighborhood, that's just him and his homie. But nowadays, if that same event hits that same neighborhood, there's a lot more homies living there. So because we have a higher density, more of us suffer the impact of natural disasters. Remember, humanity used to be really spread out. Humanity has gathered around all those white spots on the night map. Remember, humanity lives more and more in cities, less and less spread out. So when something bad happens, it hits more of us, because we're all clustered there. The other thing is, we used to live in the safer part of town, but when you add more and more citizens, they're going to end up in, more hazardous parts of town. So as cities grow, people are pushed into the more hazardous edges. Think about it. The first people that lived in La Conchita, were they right up against the hill? No, they were on the beach because that's the killer spot. The last houses built were the ones that were progressively closer to the hazardous hillside, right? Literally, the great irony of the La Conchita slide was that a lot of those people had just bought their homes or just built their homes, and that was like the leading edge of La Conchita was right where the hurricane hit. Sorry, where the landslide hit. Anybody know the other 2 reasons why disasters are getting worse?
Wouldn't it be because, like, a danger of chemicals, like, say, nuclear power plants?
Well, we might live in more dangerous times. We're like escalating hazards. That's probably true. But I want to talk about the deadliness of the disaster overall. Yeah.
Oh, land use?
Yeah, for some of them, like for flooding, exactly. The thing that we're removing the stuff that protects us. Oh, but actually that is one of these 4. The removal of natural protections. And here's one that I'm guessing you haven't thought about. Our man-made infrastructure globally is aging. Dams and harbors and bridges, they were built back in the day when labor was cheap and material was cheap and energy was cheap. I don't know if you know this, but construction has become extremely expensive. People now have more rights recognized by government, energy is more expensive, environmental reporting is more expensive. So infrastructure is aging.
Yeah, so